Okay, class, so we're going to take a look at the quotient rule, and the quotient rule is used when I have a rational expression that's a little more difficult to break apart into separate fractions. So once in a while, or actually many times, you're going to see these kinds of expressions where you're going to want to use the quotient rule. So the way I learned this is with a phrase. And so you have the calculus notation in front of you that has the f of x and the g primes of x and the g of x and the f primes of x. It's the same concept, except I'm going to use this phrase instead to kind of help me remember which piece to use. So what I'm going to do is I'm going to take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so repeat this phrase to yourself ever so often when you're doing the quotient rule, and that way you won't miss one of the terms. So let's actually use this for this problem right here. And here's my top, or my numerator, and here's my denominator, and I'm going to follow that rule that I just gave you. So let's use this guy. Alright, so if I keep my notation, I have h prime of x is equal to the bottom, which is x squared plus 4, times the derivative of the top. So using my basic differentiation rules, I get 3x squared plus 10x, close parentheses, minus the top, which is x cubed plus 5x squared minus 3 times the derivative of the bottom, which is 2x. Now, since it's the quotient rule, it is all over the bottom squared. So I'm going to take x squared plus 4 and square it. Alright, so my next step would just be to simplify this and make sure I distribute correctly. So I'm going to get h prime of x is equal to, and I'm going to distribute right here, and right here, right here, and right here, as well as right in this term, but I'm going to distribute this negative and 2 as we go through. So let's go ahead and simplify this. Get h prime of x is equal to 3x squared times squared is to the 4th plus 10x cubed squared, and x right there is cubed. Get 4 times 3 is equal to 12x squared plus 40x, right? And then I'm going to distribute these pieces, so I get a negative 2x to the 4th, and I get a minus 10x cubed minus 6x. So let's double check our work and make sure it's correct. All over x squared plus 4 squared. Right? So once again, I'm just going to simplify, and if you take a look, I have like terms here. So here's an x to the, here is an x to the 4th, and there's an x to the 4th. That's going to give me, let's scroll down just a little bit, extend my page, okay. That's going to give me an x to the 4th, right? This 10x cubed and that negative 10x cubed cancel. I get plus 12x squared, and I have like terms right here. Let me double check my signs real quickly. Oh, so if I take a look, I made a sign error right here. There's a negative and a negative right there, which will give me a positive 6x. And so if I take a look at that, I will get plus 46x all over x squared plus 4 squared. So I can leave this as my derivative. So it may seem tedious, but this is actually a lot shorter than trying to figure it out in the other method that we've used before. Okay. So let's take a look at this problem. And I'm going to throw in some trig in here, but that's fine because you guys know the derivative of trig functions. So if I take this, the derivative of y is my dy dx symbol. And I'm going to follow the phrase again, just to give us some room. The bottom, which is sine of x, times the derivative of the top is 2x. So what I'm going to do, I always like to put my trig functions towards the back. So I'm going to put the derivative up here. Minus the top, so x squared plus 3 times the derivative of the bottom, which is cosine of x, all over the bottom squared. And I'm going to get sine squared of x. Well, can I really simplify this? Not too much, so I'm actually just going to leave it at this. So, while the previous problem took a couple more steps, because we had trigonometry, it actually simplified our derivation. Alright, so now let's apply this quotient rule to figure out some other pieces. So as you've seen before, sometimes when we're finding derivatives, we don't just stop at the derivative, but we can create these equations of tangent lines. So let's go ahead and do this with a quotient rule problem. Actually, you know what? Let's do it. Let's do another problem right here. So that was my mistake. But let us solve this right here. And once again, I'm going to do the top and I'm going to do the bottom. So if I pick the correct pen, the derivative is f prime of x is equal to the bottom. And so here our bottom is x squared minus 7 times the derivative of the top. Well, what do you notice about the derivative of the top? Good, I have multiple x's here, right? So if I take a look at this, there's actually a rule embedded in this numerator. And if I do this, the first and the second, what rule is that? Let me move that down just a little bit. Let's move this up. Yeah, so what rule is that? Correct. For this numerator, to find its derivative, I actually have to use the product rule. So you're going to see that the functions are not only going to use one rule, but now you know a set of 6, and if I include the trig, that's 8 different rules that you can use within this problem. So let's continue this and actually solve using the product rule. So I'm going to use brackets just to make sure I keep everything in order. But I'm going to get the first term, 2x cubed, times the derivative of the second, which is negative sine of x, plus the second, cosine of x, times the derivative of the first, which is 6x squared. I'm going to close that parentheses. And now I've taken that first portion of the fraction, the first half of the numerator of the fraction. So I have the bottom times the derivative of the top. Okay? And then if I continue, let me make this smaller so that way it's not taking up too much space. So let's group this. And let's hope I can keep my writing small. Right? So I'm going to shrink that down just so we can take a look at it. So I'm going to continue the rule. So I had bottom times the derivative of the top minus the top, which is 2x cubed cosine of x. I'm going to put that in parentheses. Times the derivative of the bottom, and the derivative of the bottom is 2x all over the bottom squared. So x squared minus 7 squared. So I'm going to now simplify this because I have many parentheses in here. And what we're going to get is, just to simplify this nicely, I'll do this right here. And I'll get x squared minus 7 times negative 2x cubed sine of x plus 6x squared cosine of x minus 4x cubed cosine of x. And the 4 comes from this 2, that 2. Oh, and since I have x cubed and I have an x here, my exponent, this one, should actually be a cubed, x cubed times an x should give me an x to the 4th power. Then all over x squared minus 7 squared. I believe that might be just enough room that you have on your sheet of paper. So let's stop here for this, this example. Alright, so this is the end of quotient rule part 1, and I'll continue on with quotient rule part 2 in the next section. Thank you.